Hello children, welcome to class 8. You have been promoted easily into class 8, right? Anyway, we are going through difficult circumstances now. The whole world is going through a lot of trial times. Let us pray for everybody. All of you stay home and stay safe, okay? And spend quality time with your parents and help them in all that they do and enjoy yourselves, okay? Now today we will have a small maths class to help you get rid of the boredom in your homes, okay? The first chapter in class 8 mathematics is rational numbers, okay? Now we have the smallest set of numbers called natural numbers. Remember, how do natural numbers start? They start from 1, 2, 3, etc. and it goes on to infinity, correct? So this set of numbers is called natural numbers, that is denoted by the letter N. Have you understood? Now, when 0 is added to this set, then this set becomes the set of whole numbers, okay? That is denoted by the letter W. So this is natural numbers that starts from 1, 2, 3, etc. up to infinity. When 0 is added to the set, we get it as whole numbers, correct? Then the next set of numbers is known as the integers. Integers are both negative numbers and positive numbers, correct? So that can be denoted by the letter Z, yes, and we can say it comes from minus infinity up to plus infinity. Minus 2, minus 3, minus 1, 0, 1, 2, 3 up to infinity. So we have the natural numbers followed by the whole numbers, and the bigger set was a set of integers. The next set that we are going to come across is the set known as rational numbers. It is generally denoted by the letter Q. Okay. The set of rational numbers, actually we can see they are the fractions, both the negative and the positive fractions. Understand? So the negative and positive fractions are of the form P by Q, where Q is not equal to 0 and P and Q are integers. Now this is the definition of a rational number. What is a rational number? The rational number is of the form P by Q, where Q is not equal to 0 and P and Q are integers. Have you understood? Okay. Now the rational numbers can be put through many operations. Okay, we have addition, subtraction, multiplication and division. Those are the 4 basic mathematic operations. Based on that, we have different laws that we have to learn. Okay, before we go to those laws, let us do the representation of a rational number on the number line. Okay, so the number line. Okay, now the number line you have learned from very lower classes itself, right? So supposing I have like this, and we have the 0, 1, 2, 3, minus 1, minus 2, minus 3, etc. It goes on up to infinity, minus infinity to plus infinity. When we have to mark a whole number, just say we have to mark the number 2, we can just mark it here on the number line, correct? If I want, this will be x is equal to 2, is that we can mark 2 there. Supposing I want to mark number minus 1, I can just mark it here, right? This is easy. Now supposing I want to mark fractions on the number line, how will I go about it? Okay. Now supposing I want to mark 2 by 3. Okay. So if I want to mark 2 by 3, what I have to do is, first I have to draw the number line, and we'll have 0, 1, 2, 3, 4. here you have minus 1, minus 2, right? Now when it is a proper fraction, it will always exist between 0 and 1. Understand? When we have an improper fraction, it will go on to the next part. So when we have this, what is the denominator? 3. So that will give you the number of parts that 0 and 1 is going to divide it into. So 3 means I am going to divide 0 to 1 into 3 equal parts. Okay? When I want to divide it into 3 equal parts, I will take 2 divisions. Are we okay with that? Then, now this will be, first one will be 1 by 3 and this will be 2 by 3. So, can I mark 2 by 3 on the number line? Isn't it simple? Yes or no? Okay. Now supposing I want to mark the number 5 by 6. Now 5 by 6 is a rational number and it is a proper fraction. So where do you think it will exist? It will exist between 0 and 1. So once again draw the number line. 0, 1, here also make it equal, 1, minus 1, minus 2, 1 and 2 along like this we can continue. The division should be equal. Okay. Now, this is going to exist between 0 and 1, correct? So when it is going to be between 0 and 1, we have to see the denominator and accordingly divide that 0 and 1 part into that many parts required. Here we have to divide it into 6 equal parts. When we are going to divide it into 6 equal parts, how many cuts should I make? 5. Good. So we will go on to 1, 2, 3, 4, 5. Now I have marked 5 divisions. See how many parts have come in. 1, 2, 3, 4, 5, 6. Have you understood? So when I need to mark 6 parts, I will cut 5 cuts. Understand? So now you see I need to mark 5 by 6. Where will 5 by 6 come? This will be 1 by 6. This will be 2 by 6, 3 by 6, 4 by 6. So this will be 5 by 6. So I can mark it here. Have you understood? So this is how you will mark fractions on the number line. So if I give you some homework for today, you must be able to represent these fractions on the number line. Okay. Now this is on the number line. This is 1. Now the next concept that we are going to see is to find rational numbers between 2 rational numbers. Okay. Now supposing I want numbers between 1 and 2. Yes. I can have fractions between 1 and 2, right? I can have 1 1/2, right? That is 3 by 2. Yes. Or 4 by 2 is like that. So I can find fractions between 2 whole numbers. Now supposing I want to find many fractions between 1 and 2. Yes, how will I find it? So for that we have to go into this concept. Just supposing I want to know, find 2 rational numbers between 2 by 7 and 6 by 7. Okay, so what are the numbers that I can find? Between 2 by 7 and 6 by 7, I can have 3 by 7, 4 by 7 and 5 by 7. Yes, but they have asked only for 2. Even 5 by 7 is between these 2 numbers, between 2 by 7 and 6 by 7. So when the numbers are like this, we can find numbers there. Now supposing they ask, how do you find 3 rational numbers between, say 1 by 3 and 2 by 3. They want 3 rational numbers between 1 by 3 and 2 by 3. How will I find it? there are no numbers between 1 and 2 for me to write down, correct? So what I can do is, I can multiply this fraction by, let's say, 1 by 3 into 10 by 10. Now when I multiply by 10 by 10, actually I am multiplying by 1. Yes, if I cancel I get 1. So I am not changing the value of 1 by 3. I am getting an equivalent fraction. So what will I get? I will get 10 by 30. 1 into 10 is 10, 3 into 10 is 30. Now what can I do for 2 by 3? 2 by 3 into 10 by 10. So what will I get? I will get 2 into 10 is 20 and 3 into 10 is 30. So I have got two equivalent fractions. Now I can find how many? I can find 9 fractions between 10 and 10 by 30 and 20 by 30, correct? So what are the fractions I can say? 11 by 30, 12 by 30, 13 by 30, 14 by 30, 15 by 30, etc. So up to 19 by 30, correct? So haven't I found so many fractions? Yes or no? So when you want to find fractions between fractions, if they are of the same denominator, we can multiply by 10 by 10 to both the fractions and find corresponding fractions between those fractions. Did you understand? Okay, I'll give you one more example. Just say they want find 5 rational numbers between 4 by 7 and 5 by 7. Okay. Now between 4 by 7 and 5 by 7. So what is the concept I taught you? I said may find the equivalent fractions by multiplying by 10 by 10. So what will 4 by 7 become? 4 by 7 into 10 by 10 will become 40 by 70. And what will 5 by 7 into 10 by 10 become? 50 by 70. Now you can find almost 19 fractions between these two. You can take any number and say, they want only 5, right? 41 by 70, 42 by 70, 43 by 70, or even 49 by 70. Yes, and 47 by 70. Isn't it? So we have got 9, sorry, not 19 fractions, 9 fractions we can get. Here I am getting 5, the required 5. Did you understand this concept of how to find fractions between fractions? But when they are of the same denominator, it was easy. Just say that they have given different denominators. Okay? Just say they have given 1 by 2 and 2 by 3. In that case, how will you find fractions between these two when the denominator is not the same? So first bring it to the same denominator. So when you try to bring it to the same denominator, what will you do? Find the LCM of 2 and 3. What is the LCM for 2 and 3? 6. So if 6 is the number, 2 will go into 6 how many times? 3 times into 3. So 3, comma, and 3 will go into 6 how many times? 2 times 4. So the two fractions that we can say what? This will become 3 by 6 and 4 by 6. Now can we find number of fractions? By multiplying by 10 by 10 and 10 by 10. So what will you get? 3 by 6 into 10 by 10 is equal to 30 by 60, and 4 by 6 into 10 by 10 is equal to 40 by 60. So do you understand how to find the equivalent fractions? After getting this, we can find 5 rational numbers, that is 31 by 60, 32 by 60, 33 by 60, 34 by 60, 35 by 60. You can even have 36 by 60 up to 39 by 60. Did you understand? Okay, I will give you some homework. Try to represent rational numbers on the number line and find rational numbers between two given rational numbers. Okay, take care, have a nice day, stay home, stay safe.